Welcome. In this video, we're going to talk about the Energy of Electrons lab and that you can do using Pivot. And so the way this will work is when you go into Pivot and open the gas emission spectra lab, you'll see some videos and there'll be some questions and some descriptions as well. But when you look at the videos, they'll look something like this, and we're going to observe these emission spectra for various elements. So this right here is the gas on the right, and then they're shining it through like a prism, diffraction prism that is separating the light out into these various color bands right here. And the various emission spectra showing these various colors of light are going to be unique to each element. And we can use these emission spectra to identify element based on our observations. We can take measurements. If you go in the upper right hand corner to these tools, if you click on that, then it will pop up a ruler and you can record the wavelengths of light that you are seeing in the spectrum. So that's what we're looking at in this lab. And the other thing that we're going to do is we want to absorb these spectra and see what they look like and take some measurements. And the other piece of this lab is we want to do some calculations. So down here in the calculations section, you are going to pick 3 bands of light from the helium spectrum. So you're going to pick them, and then in your data, you're just going to write down the wavelengths of 3 of the different bands of light you observed in the helium spectrum. And then we are going to take those wavelengths and calculate the energy of light that we are seeing. So when we talk about electromagnetic radiation, it has characteristics. It has a wavelength, which is this distance right here. So electromagnetic radiation is a type of wave. Waves have a wavelength, which is this right here. They also have a frequency, which is measured in units of like something per time. So it has to do with how many peaks will pass by a given point per time. So we'll find that in this lab, when we calculate the frequency, the units will be in 1/seconds. So basically it's the number of like peaks that cross a given point per second. Is kind of the meaning of that. And then we can also describe an energy associated with this type of radiation as well. And there's some equations down here. You can find them on your equation sheet. And here I put a snip of them on this page, so you don't have to flip back and forth. And there's some equations that relate energy and frequency. So we can see from this equation that the energy is directly proportional to the frequency of a wavelength, and the frequency and the wavelength are inversely proportional. So wavelength times frequency equals c. What is c? It is the speed of light. So a type radiation has larger the wavelength, the lower the frequency, and vice versa. Okay, so let's do a calculation. Sample calculation. I'm not using actual data from the lab. I'm just going to pick a random wavelength. So let's say that we measure some light. It's got a wavelength of 800 nanometers. That's how we usually measure these wavelengths, is in nanometers. And we're trying to figure out what the energy is. Well, in order to find energy, we need to know the frequency. And I'm given the wavelength. So first thing I'm going to do is I'm going to use this equation down here to find my frequency given my wavelength. Okay, but notice in the table, before we find frequency, you're prompted here to find the wavelength in meters. So we want to do a unit conversion here. We are going to convert our nanometers into meters. And this is the one thing that's not given on your equation sheet that you actually need to know is your metric conversions. And so that's why I gave you in your notes here on page 20 in our slides here, I gave you a slide showing some common prefixes that you need to know. The ones that are highlighted in yellow are the metric conversions you should know, or metric prefixes, I should say. So nano means 9, basically. So there are 10 to the 9th nanometers in 1 meter. So, and you can think nano 9, that might help you remember it. There's 10 to the 9th nanometers in 1 meter. So if I'm going to plug this in to my calculator, I wish I could show you the calculator like you probably have, but the way you might type this in your calculator is you might find a button, it might say like a capital E, or it might have two capital E's, depending on what calculator you have. But you can use 800 divided by 1e9. That is a way of writing 1 times 10 to the ninth. It's a way of writing scientific notation. So anyways, plug it in your calculator. You should end up getting 8 times 10 to the negative 7. That is the wavelength in meters. Okay. And then remember, I'm trying to find energy. So in order to find energy, the next thing you have to do is find the frequency. Okay, so right now, I know the wavelength is 8 times 10 to the negative 7 meters. I want to find out what the frequency is. So I'm going to use this equation that the speed of light is the wavelength times the frequency. I'm going to rearrange it to solve for frequency. And then this value c is given right here. So you don't have to memorize any of these values. You just need to know like when and how to apply them. So the speed of light is 2.998 times 10 to the 8th meters per second. And then our wavelength is 8 times 10 to the negative 7 meters. So notice that if we stop and pay attention here to our units, which is super important, you will notice that the speed of light is in meters per second, and my wavelength is also in meters. This is why we had to do this step right here, converting my nanometers into meters, is because these units need to match in order for this math to work out. Because I want the meters to cancel out and be left with 1 over seconds, which is our unit of frequency. And I'm going to stop and plug this into my calculator. So again, the way that you might do this, like on my calculator, I would go 2.998, and there's this EE button, and I'm going to divide it by 8, EE negative 7. So if you're not sure what button I am talking about, I can always show you a tutorial, or you could ask a friend that maybe they know where it is. And then you should end up with an answer that is something in the times 10 to the 14. So you get a really big number for your frequency. In this case, it's going to be 3.74 times 10 to the 14. For your wavelengths, this number will vary, but it's going to be a big number. It should be something times 10 to the 14. And then that is your frequency. Okay, so now let's find energy. So energy is, we're going to use this equation right here, E equals HV. Okay, so energy equals Planck's constant, right here, times the frequency. All right, so let's plug that in. Here, I'll actually write over here. E equals HV. Okay, so H is Planck's constant, 6.626 times 10 to the negative 34. It's a very small number. And that JS, what that is that's joules times seconds. So J is joules. It is a measure of energy. Okay, so I'm going to take this and I'm going to multiply it by the frequency that I just found, which was over here, 3.74 times 10 to the 14. That is my frequency. 3.74 times 10 to the 14. And the units of this is 1 over second. So you might notice that when we multiply this out with your units, you end up with joules times seconds divided by seconds. So notice how my seconds are going to cancel out, and my answer is going to just be in joules. Yay! And again, plugging this in your calculator, the way I would recommend doing this is find this exponent button on your calculator. It might be 1 capital E, it might be 2 capital E's. I think it's like, I have a different calculator from you, so I forget what it looks like on your calculator, but again, I can help you out if you're not sure where to find it. I highly recommend using this button instead of typing in times 10 caret negative 34, because I often see people just make more mistakes when they type it in that way. So you're going to multiply these together. And in this case, 6.626 E 34 negative. So you should end up with something, in this case we have 2.4 times 10 to the negative 19. And my answers here are in joules. So you should end up with a really large number for the frequency and a really small number for the joules. That just kind of gives you a sense if you're on the right track with your calculations. And if you still have questions, stop by in the tutorial time, ask me questions. I'm happy to help you out. Thanks.